Maybe? No? Okay, it's recorded. Line which seems like it's going to be a little harder than... How come I can't turn on my computer? Alright, let's try it this way. There's like 5 different ways to do things in this room, and you have to find the one that works. I love this room. It's so nice. Source. Oh, great. It's giving us infinite room again. What did I just do? Source camera. Okay, so what are you seeing there in Maxwell? Just a big blank screen? That's fantastic. Stupid thing worked for me already. Select new input. Okay. Well, that didn't work. Input. Camera source. Source. Try that. So can you give us infinite screen again? Looks like it. No infinite screen anyway. This is just fantastic. I love it. You went through all that trouble and they got me nothing. Okay. I don't even know what to do. I usually just start pushing buttons until the system dies. I don't really care if the system dies, so it doesn't bother me much. Let's see here. Hide presets. Where's the button? Oh, presets. Let's see what that does. That didn't do anything. Stop presentation statistics. Swap. What does swap mean? Hide. Yeah, I'd like to hide right about now. Okay, well, that's not working. $20,000 for this stupid system and it never works. Alright, let's go back to where I was, which is camera or something like that. Open. Can you see me now? I can't see anything. That's just great. The other screen supposedly is supposed to have my computer on it, but I can't even get my computer to show anything here. Is it on? That's the beauty of it. Yeah, that's the exam. I can't even bring it up again. My computer is on, my screen is on, supposedly. I wonder if it's accidentally unplugged the screen or something. No, the screen's plugged in. Gracious, what a mess. Okay, well, I think it's Windows, isn't it? Yeah. HDMI port.
Alt F4, I believe.
Oh, to select
the screen.
Select an output.
Yeah. Brings the screen back to you.
Didn't know me, but Alt F4.
I think.
Let's just press a bunch of Alt F things. Nothing works from Alt F1 to Alt F12. All right. You like my approach to computers? I actually know a lot about computers, but just this system is so convoluted and so special. All right, well, let's forget it. So, I can do this my own way. I can teach a class without having a... Can you see anything now? Because I can't see anything. So I'm still here. Okay. I'm still here. You can see me, but I can't see you, but that's okay because I can hear you, and that's good enough. Okay. So, I want to do since we can't see anything on the computer, and I'm going to end up ending this class a little bit early and just send you your exam because nothing's working and I don't want to mess with it anymore. I'm not even sure what the point is of recording this, but I want to do a quick overview of what we've learned so far in chapters 1 through 3 and the things that you might expect to know something about on the exam. Like I said, it's nothing really technical. We start off in chapter 1 learning kind of what it takes to be an engineer, what it takes in the classroom, what it takes in real life to be an engineer. What it comes out to is that engineering is hard, and you have to know that from the very beginning. It requires a lot of math, a lot of science, and a lot of hard work. And I don't say these things to deter anyone. I don't say this to discourage you from engineering. I always want to encourage people who are willing to work hard and who are capable of the material, learning the material they need to go into engineering. I think I have this flyer here, and the flyer has, I think, the top 15 jobs that you can get with a bachelor's degree as far as the paycheck you're going to get. And of the top 15, I think 13 of them are engineering jobs. The other two are physics and actuarial mathematics, which are very related to engineering. So the top job, I think right now, has a starting salary average in the United States of $85,000 with a bachelor's degree. That's your 4-year degree. That's an extremely high paycheck. It's more than triple the paycheck that your average college graduate gets. An average college graduate gets somewhere in the $30,000 range, $35,000 to $40,000 range in their first job. Most of them around 35, not 40. So to start off in life at a much higher pay rate is definitely worth the hard work, in my opinion. But that's not the only thing that this little flyer shows, and this is information that's just come out this past year or two. The other thing that it shows is the average income that you have after you've been in the field for a little while. And those numbers are huge for engineers. So you start off, your average engineers start off between 45 and 60,000 a year, somewhere in that range. But after 10 years in the field, most engineers are up around 100,000 a year. And that is a big deal. Of course, some engineering fields pay a lot more than other engineering fields, but all of them are really high compared to all other jobs out there in the field. Since I have decided to start teaching, which was 10 or more years ago, I have been offered, I think, 2 or 3 engineering positions, each one of them, ranging in somewhere near the 6-figure range. That's a big deal, and I have very little experience in engineering. I've had one job in engineering as an electrical engineer, and that was while I was a graduate or an undergraduate student, way back in the 90s. And so it's been a long time since I've really done engineering, but the company that hired me back then has offered me a job just a couple of years ago. I went back to visit some friends at this company, and they offered me a job right on the spot. I had a guy come and ask me to work in his company that's inventing some new things for the food industry, and wanted me to come and work for him and do all this stuff. And it's not that they weren't good jobs. They were really good jobs and had really good prospects for great pay and lots of travel, interesting work. I'm just really interested in education. That's what I love to do, and so I've decided this path is for me. And it doesn't pay badly, it actually pays pretty well. Maybe not quite as well as the six-figure jobs I turned down, but I like what I do. So you have a lot of choices, and there will always be choices, and there will always be opportunities out there. My brother, who works as a civil engineer, works for the Department of Energy, and he maintains actually a munitions site for the Department of Defense as well. So he's out in California working near San Francisco, which is one of the most exciting places in the world to live and to do things. There's so many different things you can do, so many different things to see, so many different experiences to have in that place. I grew up there, so I know this. But he's getting paid enough to live in one of the most expensive places on earth, really. And he lives comfortably. He actually has a really nice house in a really nice neighborhood and lives very well on a civil engineering salary and does exciting work. There's so many engineers that I know that have so many diverse experiences. There's an engineering firm right here in North Platte that they employ, I think, 2 or 3 civil engineers, and they do bridge work and road work and building. They build buildings and other things like this. So you can do engineering just about anywhere. It doesn't matter if you're out in a very rural area like we are here in Nebraska, or if you're in the middle of 25 cities, or even if you're in some other situation, which there are other situations. So engineering has a lot of opportunities for you, and I try to encourage people to go into it because those opportunities can really change your life. However, to succeed, to survive is actually a better word, you really do have to approach it correctly. You have to learn how to organize yourself. You have to learn how to be a good student. You cannot survive in engineering if you cannot manage your time, if you cannot manage your resources, including money, including whatever, anything that comes your way. If you can't manage it efficiently and effectively, you're not going to do well as an engineer, because engineers have to be efficient and effective in everything that they do, especially while they're students, but also when they become engineers. What kind of engineering schools are out there nearby? Well, in the state of Nebraska, you have 3 choices. You have University of Nebraska at Lincoln, which is the main campus for engineering in the University of Nebraska system, and the University of Nebraska Omaha, which also has a brand new facility called the Peter Hewitt Center, which mostly is concentrating on construction engineering and systems engineering, civil engineering, things like building buildings and designing the systems within buildings and things like that. So you have those 2 schools, and then you also have the Creighton, I believe, has an engineering program. And that's it. I think those are the only 3 schools in Nebraska, 2 in Omaha, 1 in Lincoln, that have engineering programs. We teach, of course, some engineering courses, but we are not technically an engineering program because we can't take you all the way through your bachelor's degree. But the courses that we offer include this course, another similar course to this that is kind of an advanced version where we do more involved engineering work, more real engineering projects, and it's mostly geared towards students that are actually here on the campus. Another reason we made this class is because we can do this class at the high schools. But then we also teach a MATLAB course. MATLAB is a program that was designed specifically for calculating engineering type problems and for modeling engineering type problems. It's a very powerful program. You can do a lot with it. And we teach a course in MATLAB, and that one we will be teaching next semester, and you can take that as a high school student if you'd like to. It has no prerequisite, just like this course, but it's helpful to have a fair amount of experience in algebra so you can just make your life a little bit easier. But that's something that all engineers have to take, so it transfers to almost any engineering school. And then we have 2 advanced engineering courses that you cannot take until after you have taken your first year of calculus and your first year of physics. It's required to have those courses out of the way. So actually, very few of my students actually get into those courses before they leave here, because most of my students are working towards physics and calculus, not finishing calculus and physics. So those two courses are an electronics course that every engineer has to take. No matter what kind of engineering you go into, you have to take an electronics course, because electronics are used in every kind of engineering. And then what is called engineering mechanics engineering mechanics statics, which is a course that all civil engineers have to take and all mechanical engineers have to take, all mechatronics engineers have to take, but not necessarily electronics engineers. Chemical engineers don't have to take that course. And there's, other engineers, computer engineers, software engineers, they don't have to take that course. So it's more specific to the more mechanical types of engineering. So we can essentially take you through your first year or two of engineering and get you a lot of science and math and a few engineering courses under your belt, so that when you transfer to whatever school you go to, you are not transferring over starting in freshman engineering courses. You've already got a few of those out of your way, and you can transfer in as a late term sophomore or even early term junior, which is nice, because by the time you transfer from a community college, you're usually already 21, 22 years old, and you don't want to transfer over as a freshman. You prefer to take courses with people more your age. So, we also talked about a lot of the different fields in engineering. For example, civil engineering, which we've already mentioned, mechanical engineering, which we've already mentioned, electrical engineering, so on and so forth. Each one of these fields has subfields within them. In civil engineering, you have architectural engineering, and you have let's see what they have hydrology, which is the study of how groundwater affects structures. They have construction engineering, environmental engineering, geotechnical engineering, transportation engineering. These are all types of civil engineers. And then mechanical engineering has many subfields, electrical engineering has many subfields, and so on and so forth. There are many of these engineering fields out there that are very similar. And so the thing that interests you might fall under chemical engineering, but it might also fall under electrical engineering, because there are such things that do fall under both fields. They're kind of an intermixture. So you have to kind of decide as you're going through school, what kind of engineering you're going to specialize in that will work best for the things that interest you. And by the time you're done with school, your interest may have changed, or you may have developed an interest you didn't even know you had. And when you leave school, you may develop new interests, or you may be kind of funneled into a particular direction that you hadn't intended to go just because of circumstances. It happens all the time. It's how I actually got into teaching. I had no intention of being a teacher when I was in school, and I wasn't studying to be a teacher in any way, shape, or form. And it just kind of got led this way by a set of circumstances that I was not anticipating. So you have to be aware of that. One of the other things we talked about is the professional societies of engineers. There are many of these. Just about every field of engineering has their own professional society, but there are some general professional societies. For example, the Society for Professional Engineers. I think it's Society of Professional Engineers of America or something like this. But a lot of people belong to these societies so that they can go to the meetings and they get news. They get like a magazine every month that talks about what's going on in engineering. They get email alerts, and they also are connected with a lot of engineers in a lot of ways through these societies. They go to meetings regularly, and this is one of the ways that engineers do quite a bit of their traveling. They travel to meet with other engineers to discuss their work, to trade ideas, to collaborate, and so on. And I mean, I don't travel that much, and I'm not really an engineer because I'm mostly a teacher. But I've just recently been to, I think the last place I went to was Vancouver, Canada. Went to a meeting there, and I've been all over the United States for engineering and physics meetings. Outside the United States, Canada is the only one. But my brother, my youngest brother, he's been all over Europe for engineering meetings. My father has been all over the world for engineering meetings. So you have opportunities to travel as well and to get to know new cultures and new people all over the place. The last thing that I want to mention about what we've learned, the last two things, is we learned about the engineering design cycle, and that is an important thing, and there's a video on that online, and I won't have time to talk much about it here since we're almost done. So much for ending early. But then Chapter 3 is all about engineering ethics and the problems that can arise as you're doing engineering. You can have all kinds of issues that arise. And certainly the design cycle and engineering ethics are something that you need to learn about as we go forward for this exam. So get into the videos on YouTube and watch those thoroughly. Learn as much as you can. If you have any questions, send me an email, you can call, whatever. And I'll be happy to answer them. And I will send out this exam to you as soon as we are done here in the next 30 seconds. Do you have any questions? Okay, I will talk to my technical people and have them try to fix this again so that maybe we can have a more normal type of experience in this class. Have a good weekend. Look for that exam and get started on it, and we will see you all on Monday. Thank you. Have a good one.
Here's the homework. It's rather simple.